Hello, my name is Hania Habib. I'm a computer engineering student at College University, and in this video I will represent my advanced computer programming course project, which is CST risk prediction using machine learning and fast API. CST is coronary heart disease, by the way. So the goal of this project is to build an end-to-end system that can predict the 10-year risk of coronary heart diseases or CHD using a real medical data set, machine learning models, and RESTful API implemented with fast API. So from the starting of the data set, I will show my data set, then my UML overview diagram, then the system architecture, the Python code for training the model, the fast API code that turns into an API, and then a live demonstration using Swagger UI where I send JSON request and see the predictions. So first of all, I have the UML overview diagram. So let me start with this UML style overview diagram of my project. At the very top, you can see that the box labeled patient CST dataset. This represents the Framingham Heart Study dataset that I used. It's a real medical dataset containing patient information like age, blood pressure, cholesterol, smoking status, diabetes, and so on. And the label in the dataset is 10-year CHD, which tells us whether the patient develops CHD within 10 years. So from this dataset box, an arrow goes down to analyze 16 featuring features. Here I'm basically doing feature analysis, and I read the CSV file into a pandas data frame, explore the columns which features are medically meaningful, and I include age, current smoker, cigarettes per day, systolic and diastolic, blood pressure, total cholesterol, etc. The next box is multiple ML models, which represent the phase where I try several machine learning algorithms. So in my code, I experiment with models such as logistic regression, decision trees, support vector machine, etc. And below that is train model on CST dataset. Here I split the dataset into training and test sets, typically like 80%. And in the center of the diagram, we then move to the box called select best model. And one of the model I selected, the arrow goes to the convert best model to API, which means that I save the trained random office into a .pkl file using the joblib library. And then I load the model inside a FastAPI application. And finally, the diagram ends at the end circle after successful deployment. Now it has the system architectural diagram, which flows between components. On the left side, you see data pre-processing and feature engineering. This corresponds to my Python script where I load the Framingham Heart Study CSVs. And right after pre-processing, the data goes into the ML model training block. Here implements several algorithms, but my main training script is mltrain.csd.py. In this file, I import libraries like pandas, skitlearn, and joblib, and I do a train test split with 80% training and 20% testing. And I train a random forest classifier. And the model's performance is evaluated by computer accuracy and printing a full classification report. So if the accuracy is good, I save this trained model into the model storage block as models, and then best model.pkl. In the middle, you see a big block labeled FastAPI API, and this is implemented inside my CSTAPI.py file, and it shows when this FastAPI actually starts. It loads the best model.pkl using joblib and load and define several endpoints like post predict, post records, get records, record ID, push records, record ID, delayed records ID, record ID. So this means that my APS not only doing predictions but also demonstrates full CRUD operations, which is a requirement of the project. And then bottom right you see user client sends JSON predicts. Overall, this architecture diagram shows how the offline training pipeline on the left is connected to the online API service on the right, with the pre-trained model file sitting between them. Now these are my codes, like my dataset and ML training code. So in this part I will talk about the coding part, starting with the dataset and model training. The dataset I'm using is saved as CST underscore data.csv. It is a clean version of the Framingham Heart Study dataset. In my code I first import pandas SPD, and then I read the CSV using df equals to pd.read underscore CSV and then CSV underscore part, where the path points to the data folder in my project. After loading, I print df shape and df head just to confirm that the dataset has about like 4,238 rows and 16 columns. And then it just goes like x and y, and then I use train test split. After training, I put the predict on the test using y pred equals to model predict, and then I calculate accuracy. So it is like a reusable model file that I can load inside any Python application, including FastAPI. And then FastAPI code, how it works is dash in my chd underscore api.py. First, I import FastAPI and pydantic. I create the app with app equals to FastAPI title, which is CST risk prediction API. And then I also load the model as startup using something like model equals to joblib.load and then model underscore path, where model path points to models best model.pkl. So the main prediction endpoint is, just to get like main things like male, integer, and then age, float, education, float, current smoker, integer, cigarettes per day, float, like data like this. And then data like post records, take up patient's features, objects, add an ID, and stores it in the list and returns the record created records. So get records returns the full list, get records record ID searches the list by ID and returns a matching record. Put records ID replaces the record with an updated one, and delete records ID removes it from the list. To run the API, I use the command like uvicorn csd underscore API and then API reload. And then I use the swagger, which shows that when I open my link, I see a page title CSD risk prediction API, and all my endpoints are listed as get root endpoint, post predict, get record, post records, get records, put records, and delete records. And then you can see all the examples on it. And then I also tested in the examples and in the summary. I use this project. I implemented a full machine learning and API pipeline for predicting 10-year coronary heart disease risk. So for that, as I mentioned, I used Framingham Heart Disease dataset, analyzed 16 key medical and lifestyle features. I trained several machine learning models and selected random forest as the best one, saving it as best model.pkl. I built a FastAPI backend. I used Swagger UI, and that's it.